everyone, welcome to my channel Euclid Mathematics. Today I am here with the solution series of Linear Algebra. So here we are solving previous year question from different type of the exams like NET, SET, GATE exams and multiple other also. So here in my today's video I am here with the question from CSIR NET June 2017. It is a 3 marks question and similar type of the question which asked in a GATE exam and other competitive exam too. So for your understanding of a concept, you need to solve similar example. Okay, so here in my today's video, our example which is based on characteristic polynomial or minimal polynomial of a matrix. Okay, so here in my question, let's read our question. Question is for 3 marks and which asked in June 2017. So 43 number question. So here matrix A is given 3 by 3 matrix is there, and which is having element 1 0 2 1 minus 2 0 0 0 minus 3. And identity matrix is also given, which is a 3 by 3 identity matrix. Okay, and if 6 into A inverse, which is equal to A into capital A square plus small b into capital A plus small c into capital I. Okay, so we have some certain type of polynomial here. Okay, and that polynomial which is in the form of a, okay, it is a quadratic polynomial look like. Okay, so for ABC belongs to R, then we have to find out the value for A, B and C, interval ABC. Okay, so we want the value for ABC. So here option it is given here for a value for A1, B2 and C1. Similarly for A, B, C and similarly for ABC values are given. Okay, so we have to find out which one of the option is correct. Okay, between all these 4 options. But it is easier to answer here because of that our question it is given some type of certain type of a polynomial. Okay, so it is quadratic polynomial here for other side and it is here 6A inverse. So we can think here that matrix, if we convert that matrix into the characteristic polynomial or minimal polynomial or conversion of matrix to the polynomial, okay, so it gives us the answer of that question. Okay, so 6A inverse which is equal to A into capital A square plus BA plus CI. Okay, so let's try to convert our matrix in such a type of a polynomial and let's see how it look like. Okay, so we can see here 6A inverse which is equal to A square plus BA plus CI. Let's consider this polynomial. Okay, so let's go for the solution. So try to convert our polynomial into the some characteristic type of equation. Okay, so here determinant of matrix is the 6 here. That means matrix is invertible. Okay, that means determinant is non-zero. So we know that our matrix is a 3 by 3. Okay, and if matrix is a 3 by 3, then we use a characteristic polynomial. Okay, if matrix is a 3 by 3, then we use characteristic polynomial as x cube minus trace of A into x square. That means we want the trace of matrix A into x square plus m11 plus m22 plus m33. Okay, into x minus determinant of A which is equal to 0. Okay, so we know that trace of A into trace of A it is here. Okay, that is the addition of diagonal. Okay, x cube it is a okay variable, it is here x square for the conversion of our matrix into the quadratic form. Okay, so x it is here, but determinant it is also easier to find out. Okay, but what about m11 m22 m33? So m11 represent minor of first element. Okay, so m11 means for example, if we take this matrix, what is the m11 for that matrix? M11 means minor of this element. Minor of this element means the value for determinant of this 2 by 2 matrix. Okay, so this is the minor of m11. Okay, so the value for this determinant plus m22 means this is the second element A22, second row, second column, and minor we want for that 2 1. So make it bracket here. So we want the determinant for these 4 elements. Okay, and similarly for m33, do it for m33, it is easier. Okay, so I hope so you can find these ones. Okay, m11 m22 m33. Okay, it is easier. Now x cube remains same. Trace of matrix is a minus 4. Add their diagonals. Okay, if we add that diagonal we get the minus 4 as a trace. X square it remains same. First minor m11. Okay, m11 means keep 1 common here and then it is here minus 2 into 3, minus 2 into minus 3 plus 6 and minus 0 remain there. Okay, so it is remains 6 plus m22 here, m33 here into x. Okay, and determinant of matrix is a 6. Try to solve that polynomial further. So x cube minus 4 plus 4 x square plus 6 minus 3. Okay, 6 minus 3 what it remain 3. Okay, and go for minus 2x. Okay, so we have to add some of the here. Then 6 minus 3 minus 2 it comes 1 only. Okay, minus 3 minus 2 minus 5 and 6 minus 5 is 1. And 1 multiplied by x, it remains x. Okay, so minus 6 it is here and which is equal to 0. So x cube plus 4x square plus x minus 6 is a 0. So it represents the characteristic polynomial of our 3 by 3 matrix. Okay, so now our further task is that to compare that characteristic polynomial with the given quadratic equation in our example. Okay, so our quadratic equation, it is here in the form of A. Okay, and every matrix satisfy its characteristic polynomial. Okay, every matrix satisfy its characteristic polynomial. This one is the Cayley-Hamiltonian theorem. Okay, so it's we have to apply that theorem. It is here. Okay, so every matrix, that means matrix A satisfy this characteristic polynomial by Cayley-Hamiltonian theorem. Okay, so replace that x by A, because A satisfy the polynomial means if we substitute that value into that matrix, into that quadratic equation which satisfy that quadratic equation. Okay, so substitute here, x cube means A cube plus 4A square plus A minus 6, which is equal to 0. Okay, and here we want the value for 6A inverse. Okay, 6A inverse. So try to convert in the form of 6A inverse. Okay, so we have to adjust some of the terms here itself. Okay, so A cube plus 4A square plus A minus 6, which is equal to 0. Take it a other side, multiplied A inverse to the both side. Okay, so we will get the required polynomial. Okay, so let's go for the further step. So here it is the polynomial A square plus 4A plus I, which is equal to 6A inverse. I multiplied A inverse to the both side. Okay, so compare our polynomial with our given polynomial in our equation. Okay, A into A square plus BA plus CI, which is equal to 6A inverse. Okay, so A represent 1, B represent 4, and C represent 1. Okay, and 6A inverse remains same. So we have to worried about the value for ABC only. Okay, because we don't have to go for 6A inverse. It is nothing to do with that. Okay, so we want the value for ABC. So we got the value for ABC as 1, 4, 1 respectively. Now let's verify our question. So in our question, it says that first option is ABC 1 to 1, which is wrong. We got the value for A1, B4, and C1. Okay, so B, which is also wrong, C, which is also wrong, and D option is correct. Okay, so see how easy that question. Okay, so it is just a conceptual based question. You need to understand first of all characteristic polynomial of matrix and how to find the characteristic polynomial. Okay, so I hope so you all have understood my today's lecture. It's quite easy to understand this one. Just need a basic concept related to the linear algebra. Okay, so if you wanted to see more examples similar like this, you can check my playlist. So if you have any comments, any doubts, you can comment me in my comment box. Okay, so thank you everyone. Thank you for my today's lecture.